Whenever we differentiate, we should never lose sight of the fact that dy dx is the gradient function. What exactly does this mean? Dy dx is the gradient function. This means that if we want to know what the gradient is on a given curve at any point, we can use dy dx to tell us this. Suppose we want to know the gradient on the curve y equals x cubed minus 4x at the point 2, 0. First we differentiate to find the gradient function, so we differentiate this expression. Dy dx is 3x squared minus 4. We then evaluate this using the value x equals 2, which comes from the coordinate here. So dy dx is equal to 3 times 2 squared take away 4, which is 12 take away 4, which is 8. So the gradient of this curve at this point is 8. Suppose we want to find the coordinates of the points where the curve y is x cubed minus 9x squared plus 16x plus 20 has a gradient of minus 8. First we differentiate to find the gradient function. Dy dx will be 3x squared minus 18x plus 16. We know this is the gradient function. If we want where the gradient is minus 8, we need to set dy dx equal to minus 8. This is the gradient function. This is the gradient. So setting the gradient function equal to the gradient will enable us to find the values of x. So 3x squared minus 18x plus 16 is minus 8. This gives us 3x squared minus 18x plus 24 is equal to 0, and dividing through by 3 gives x squared minus 6x plus 8 is 0. This quadratic can be solved by factorizing. X minus 4, x minus 2 is 0. This gives us x equals 4, or x equals 2. We were asked to find coordinates, so we need to take these values and substitute into the original equation in order to find corresponding y values. If x is 4, y is 4 cubed, take away 9 times 4 squared, plus 16 times 4 plus 20, which gives us y is 4. If x is 2, y is equal to 2 cubed, take away 9 times 2 squared, plus 16 times 2 plus 20. So y is 24. So the gradient of our curve is minus 8 at the points 4, 4 and 2, 24.